Let's evaluate cosine of sine, inverse of square root of 2 over 3. We'll solve this step by step using trigonometric identities and the Pythagorean theorem. First, let's understand what sine inverse means. When we see sine inverse of some value, we can think of it as an angle whose sine equals that value. Let's call this angle theta. This means that the sine of theta equals square root of 2 over 3. We can represent this with a right triangle. In this right triangle, the opposite side is square root of 2, the hypotenuse is 3, and we need to find the adjacent side. Remember that sine of theta equals opposite over hypotenuse, which is square root of 2 over 3, and cosine of theta equals adjacent over hypotenuse. This is what we're trying to find. We can use the Pythagorean theorem to find the adjacent side. The square of the hypotenuse equals the sum of squares of the other two sides. Let's solve this step by step. 3 squared is 9. Square root of 2 squared is 2. So, adjacent squared equals 7. Therefore, cosine of sine, inverse of square root of 2 over 3 equals square root of 7 over 3. And that's our final answer. Thank you for watching.